be talking about limits. Now, last we discussed about introduction to calculus, whereby I introduced what calculus simply entails to you. So the first under while the explaining calculus, we talked about two branches of calculus, which are the differentiation and integration and we'll be dealing with this first. So after that we move to the integration. So after that I talked about we have many methods of like I said, differentiation is simply explaining method of limiting a particular value or function in calculus. So I talked about many methods that existed, and one of them is limits. So we'll be starting with limits. So from limit, because the reason we'll be starting with limits is because there is no differentiation without limits. So it is actually the basis of everything we do. So possibly we'll be dealing with limit all through in this video. So I'd like you to follow to the end and find out how to limit and find out what limit simply means and what it simply entails. So now limit. Now, for instance, I have this curve. Then I now have 2 points, P, another point here, Q. Now in in physics there and also in maths, coordinate geometry, we must avail of something called tangent. There is a straight line like this, then the circle continues from there. Now the circle is actually exactly touching the curve of the circle, the segment of the circle, without penetrating the circle. At the same time, it's not like it's just approaching. So now we have 3 types of chords like that in mathematics. Possibly we have another like this. Now the first one referred to as chord, whereby the largest chord of a circle, of a curve, of a circle rather, is referred to as the diameter. Diameter, and that name for diameter is actually the largest chord, but it is also cutting through the circle. It's just that it's the largest we can have as a chord of a circle, of any circle. Now the one that is now touching the circle, the segment of the circle, that is not penetrating into the circle and at the same time touching it, is actually known as the tangent. It's actually known as the tangent of the circle. Now the one that is not touching, but it is also part of the circle, is referred. For instance, let me assume I have a triangle like this. So I now have something like this. This is a circle. Now what I'm explaining, these 3 things, they're actually here. Here I have my tangent. Here I have my chord. And here, this line also has its function. So that's why I said it is possible for us to have a line that is not touching the circle, but at the same time part of the circle. So this is known as the asymptosis. So all these are actually part of a circle. If you have something, or if there is a kind of this scenario, possibly. So this is just it. So now, I'm just saying is just I want to discuss tangent in this case. Now, what's tangent? Tangent is now actually defined as a line that touches a curve without penetrating the curve. You don't get it? It touches it at the same time not penetrating. So now, if I should say, okay, this is a curve now, then I should just draw a line like this. Just parallel is not too straight. Now, this line is tangential. It's tangential to this curve. It's a tangent of this curve. Maybe it has points R. Let me just name it out. I don't know if you are getting me. That's that about tangent. So now, that's that about tangent. Now let's come back to limit. Now let's now assume these 2 points are joined together. Okay, I think it's quite perfect. Okay, now this is point P, this is point Q. They are not together. So this place is line PQ. Now I'm now told that okay, I have a broken line. This is my x-axis here. X-axis. And here I have my y-axis. So here I have my first x value, which is x1. So here I'll be having my what? My second x value, which is my s2. Here also I have my first y value, which is y1, and here I have my second y value, which is my y2. So if I'm to complement this thing, I'm having a triangle. I'm having a triangle 90 degrees. So actually here is also what my y1, y2, x2, x1. So now in RPT, let me assume unique numbers. If this is my price column, this is my price axis, and this is my quantity axis. Now, if there's an increase in quantity demanded, what happened? There is a change in the quantity. If a price of a particular commodity was y1 and now it has increased to y2, actually what happened? This place to this place is actually the change in the price. The change in the price. I don't know if you're getting it. From here to this place is actually the change, because originally it was y1 and now it has increased. So the change will start from here. Maybe like I was selling, okay, this matter was sold for 100 naira and now it is now 150. The change there is 15 naira. That is from the previous price to the present price. That's the difference in the present price to the previous price. That's what it's about, change in y. So I can say from here to here is actually my change in y, which is equal to what? y2 minus y1. And here also I'll be having s2 minus x1, which is my what? My change in x. So that's where slope comes in. The gradient represented with a n is equal to what? The change in y over the change in x. So then, therefore, I can have my y2 minus y1 all over s2 minus x1 as my what? As my slope. As my slope. And this is what brings about calculus. This is what brings about limits. This is not where I'm going actually. Now, where it is now related to limits is that now imagine this quantity, this q now approaches p. The p was here. Let's now assume this q is coming towards p. This q here is coming towards what? Towards p. It's coming what? Towards p. What happens? It will reduce to this. Let me name this one Q naught, Q1, Q2, and so on like that. Now we'll find out this Q is approaching our P. So the question now is I'm beginning to introduce limits to this thing. So now if as Q approaches P, what happens to my change in X? What happens to my change in Y and my change in X? Now, as it at Q naught, what happens to my change in Y? My change in Y is reducing, right? At the same time, my change in Y is also approaching what? Is approaching Y1. I don't know if you are getting it. Okay, I don't know if this is clear. It's approaching YY. At the same time, as it's reducing, it is also what? Approaching Y1. What of my changiness? My changiness, as say, it is also reducing. It is also what? Reducing and approaching what? X1. So there is a change in both as Q is approaching P. As well as Q is approaching P, there is a change. There is a change. Okay, let me now assume this is X and this is X1. This is Y and this is Y1. Y1. They are still the same thing. It's just in here. Okay. Y1 minus Y. Okay, it is approaching Y here also and next here. Now, as this is approaching it, now this point precisely is our change in X. Is our change in X, and here I have what? My change in Y at this point. So as it is, once it gets to Q1 again, okay, as it approaches this now, for Q naught, what's it called? For Q naught, they both reduce. Q1 also reduce. Q2 they reduce. Now, before it gets to P, something would happen. That's what. Now, when we talk about limit and when we talk about when something is approaching something, it does not mean it is there. When I say P is equal to Q, it's different from P tends to be Q. Q is only trying to assume the position of P in this case. But in this case, they are the same thing, no difference. But in this case, it's only assuming it. It's not there yet. So between, if I say, okay, for instance, okay, let me assume I have an x-axis and of 0, here 1, 2, 3, I have minus 1, I have minus 2. Now, let me assume, okay, this is my point P. This is now my Q1, this is my Q1, and this is my Q2. Let's now assume Q approaches point P. It will be coming from here. Now, when it will, the question is, let it only approach it. So in that case, it will approach, it will come back to, even though it wants to get close, the closer it gets, the closer, it will never get there. Provided it is talking about limits. So now, when I get here, it will approach, from here 1.9, here 1.8, then 1.7, 1.6 to 1.3, 1.2, 1.1. When it gets to 1.1, you think it's 1, but it's not 1 yet. It will come back to 1.09, 1.08, 1.05, 1.02, 1.01. Again, to go at 1.001, it's trying to reduce, but do you mind it? It's not touching P. It is only getting closer. That's what limit simply explains. When something is approaching, but still not touching, that's what it simply means in summary. So just like what I've just said here, what I've just said here, it is approaching. So when it gets to Q2, it may get to, okay, let me assume it gets to Q3, okay, it gets to Q99, it gets to Q999, then it gets to Q1000, Q10,000, Q100,000. It's only approaching, but it is not yet what? P. That is what it is only. So the point is, if I should tell you, okay, P is equal to 2. Are you getting it? Okay, from there, P is equal to 1. From here, P is equal to 1. Okay, now Q now approaches P. What happens? Q will get to 1.01. It will get to 1.001. To get to 1.00001. 1.000000001. Mind you, is not getting to P. But when we approximate this, they are still what? 1. So when we talk about limit, it's talking about it is approximately that value, but it is not that value. So if I should tell you, oh, I solved a particular question, x is now equal to 3.142. Oh yeah, okay, I checked pi. Then I now saw, okay, pi is equal to 3.142. Do you know it's not even 3.142? It is only assuming 3.142. Because it's more than this. It's about maybe 3.1418. I think I put like that. So it is an infinite series. It doesn't stop, it doesn't have an end. That's pi, including our Euler's constant. 2.71. If I say, okay, 2.7183, this is just, it's only tending to be this value, but it's not this value. So if I'm to have 2.71828446, it still continues, no end. This one still continues. They are infinite. That's what limit simply explains. So when I say, oh, pi is equal to 22/7, and then, okay, pi is equal to 3.142, it only tends to be that value. It's only assuming that value because we are only giving an approximate value of it, but not the actual value. So limit is simply when it's simply an assuming value of a particular quantity. That's just what limit is in summary. For instance, y is equal to x squared. Okay, now I now said, okay, limit x to tend to be 2. I'm trying to say assume x to be 2. So if I'm to assume x to be 2 here, I will say my y is equal to 2 squared, which is equal to 4, right? And at the same time, if I'm now to make it right, I'll say, okay, let me draw my table again. This is 0.0, 1, 2, right? 3, 4. Here I have -1, -2, and so on. Now the point is this. And I said, okay, if y is equal to x squared, right? Let x the value of my x, let it tend to be 2. That is, let the value of x, let it approach 2. The question is just if y is equal to x squared, that is, let it tends to be 2. So what will happen if it tends to be 2? Now let's solve. We'll solve it in 2 ways. There are 2 types of limit. No, not actually types of limit, but there are 2 ways in which limits can work. It can work from the left, and from the right. So if x, everything here is, they are all on x axis actually. So I'm trying to tend towards this thing to be y. I get it. Okay, if x will approach 2 from the right, what if it will approach it from the left? This is known as the left limit. So from the right, it will start from 4. So let's now say x, as y is equals to x squared. So let's say my y is equal to 4. Let's assume it's starting from 4. I have 16 here, right? Okay, let's go ahead and say when it is 3. X value actually is approaching 2. Then here I have 9. Y, we won't say it is 2. What's the next smallest number after 3 that is closest to 2? I'll have 3. I'll have 2.1, right? All squared. 4.41, right? Okay, let's now move on. What if y is now equal to 2.01 all squared? I'll be having 4.0401. Now you will now find out every value we are getting is only approaching 2, but we have not said 2 yet. That's from the right. Now let's now say from the left now. So this is the right limit. So now let's check for the left limit now. For the left limit. So actually, let's now assume the x starts from 0. So y is equal to x squared now. So my y is equal to, what's my x? Let's start from 0. Just to give us 0, right? My y here too, let's move to 1 to be equal to what? 1. So my y here, let's don't start from negative 1. So still give us 1, then 0, so still give me 0, then 1 squared to still give me 1. Then we are not going to 2 yet because we are only approaching it according to the law. Only tends to, we're only approaching, we are not making it equal to 2 precisely. So now, once the approach, we are having 1.9 all squared. I think I can get now 1.9 is not 2. 1.9 is also is not 2. It is only it is approximately, if you check it, check here too. 2.01 is approximately 2, but it's not 2. I don't know if you can get me. So now I'm having 1.19 here. 1.19 all squared to 3.61. 1.9 is equal to 3.9601, and so on. Now check the value of y. Value of y here approximately is equal to 4. Value of y here also approximately is also equal to what? 4. It's also approximately equal to what? Equal to 4. So the direct substitution method is actually a way of using it directly. That is, applying it directly is actually a way of, is more or less like a shortcut. So instead of doing this and doing this first, or doing one of them, your time would have gone. So possibly you can just apply it directly. So that's also limit implement. So limit only explains, is only talking about when something approaches but never touches. So that's what it simply explains, and this is just it. The right and the left means they all approach 4 as the value of y, but they are not equal to 4. Same thing here. Approximately they are 4. You get the point? So when I'm talking about it, means more or less like approach. So just like assume x to be approximately equals to 2.